Reducing our carbon footprint is important for Williams, as it is for every organisation. So here in our facility we've taken many steps to try and reduce our energy consumption in our manufacturing processes and in some of our development processes. We firmly believe that if you want to make a difference to something, the most important thing is to measure it. So many years ago we started to measure the energy consumed on this site and the CO2 emissions that result from that. We were the first F1 team to subscribe to the Carbon Disclosure Project, so we've been making public our CO2 emissions for everyone to see, and they can see the results of our initiatives to reduce them. Those initiatives include changing our air conditioning units to be much more efficient, changing the gas boilers, and every time we select a new machine tool, for example, we always look at the energy consumed by that machine before we make our final selection. We do everything we can to try and make our staff aware of their own energy consumption, both at home and at work, and encourage them to reduce that where possible. And we have recycling stations around the place, so we can recycle a lot of waste, and we recycle all of the materials that we possibly can from the manufacture of the F1 cars. But more broadly than that, we're also developing technologies that can help other organisations to reduce their own carbon footprint. And we're doing that by adapting some of the technologies that we've developed for Formula One racing. So within Williams Hybrid Power, we're developing flywheel energy storage as an alternative to chemical batteries.
Williams Hybrid Power has been running since 2007. And was originally just focused on Formula One and bringing KERS technology to Formula One. We help to make better use of the energy that's available on a vehicle. On a hybrid bus application, for example, when the bus breaks into the bus stop, an electric motor in the drivetrain generates electricity which goes to our electric flywheel. It then speeds up to a very high speed, 45,000 RPM. That's then in its charged state, storing energy, which can be reused when the bus leaves the bus stop. The flywheel then slows down, electricity is returned to the drivetrain to propel the bus. And that way the internal combustion engine works less hard and so less fuel is used, and there's an energy save.
The flywheel technology being developed and commercialized in Qatar is very similar in principle to the flywheel technology being developed by WHP in the UK. At the WTCQ, we are deploying large stationary flywheel energy systems to improve energy efficiency in a variety of different applications, such as mass transportation, renewable energy, and other industrial processes.
Our technology offers an affordable solution for hybridization of public transport. It offers significant fuel save and associated emissions benefit.
So we're working with Go Ahead Buses in London to hybridize some of their buses and to see if we can save as much as 30% of the fuel on those buses by using our flywheel as part of an integrated hybrid system. We're also working with Jaguar to adapt our battery technology, our battery management systems, and our complete hybrid system capability for use with a new hybrid supercar, the CX-75. Now, this will be a groundbreaking vehicle that will have extremely low CO2 emissions and fantastic performance on the road, showing what you can do when you take the best of automotive technology and combine that with the best of technology developed for Formula One racing.
In 5 years' time, we'd like to see our technology currently being developed in Qatar, used in multiple metros across the world. We also see the technology being applied in a range of different, unique renewable energy applications.
The electric flywheel technology is an example of how Williams can take Formula One technology and adapt it for a real-world benefit.